Hello everybody, welcome to this video where we'll be talking about process analysis. So in this video, I'm going to introduce you to process analysis, and in a series of videos that follow these, I will talk about how you evaluate processes and how you evaluate labor costs and processes and so on, right? So let's get started. What's a process? So a process is a set of activities that takes inputs and produces outputs. When you think about processes, you don't just have to think about processes at a very low level. For example, a process could be something as simple as, say, if you go to McDonald's and order a cheeseburger, once you place the order for a cheeseburger, everything that happens is a process, right? You place an order for a cheeseburger, the order goes to the back end where a ticket is generated. A person looks at the ticket or looks at a screen. They know that you want a cheeseburger, and they assemble the cheeseburger for you, and then put it in a wrapper, and you collect it. So that's the whole process. So that's a very small process, but you could think about process at a very aggregate level also. You could think of process as what did, say, we look at an example later on in this video of, say, Kohl's and Walmart. What was Kohl's process for the whole year? Right, so they took in some capital inputs, they took on some debt, they sold a lot of clothes, they sold a lot of accessories, they sold things in stores, online, they paid their employees. So they did a bunch of things during the year, and at the end of the year they made some money. So this whole thing is also a process. So process can be defined at an aggregate level, or process can be defined at the lowest possible level, depending upon how you look at it. The tools for understanding processes are very similar, irrespective of what level you look at, and that's what we'll talk about. So in this video, we'll define some basic terms and terminology around processes, and in further videos in the series, we'll talk about how you evaluate processes, how you compare processes, and how do you evaluate people who work in a process and so on. Right. So here are simple examples. So if you in a university, the inputs are students and the outputs are alumni. So that's a funny way of looking at that. And in a factory, the inputs are all the raw material that you put in. And say, for example, in a guitar factory, it's guitars that come out. Right. So processes can involve both goods and services. Say, for example, input to a call center is a person placing a call. The output to a call center is either a person whose call was answered or a person who's going to give you a call back. So either way, so process can involve both goods or services, and each process doesn't even have to have a single input. You can have multiple inputs within the same process. We'll talk about all of that in these series of videos. Right. So when looking at a process, one of the first things that you do is you define a flow unit. What is the one unit, singular unit that you're going to consider flowing through? So going back to the university example, it's a person who goes from being a student to an alumni. If you're looking at, say, blood donation, it's how many pints of blood were you able to collect. So that is one flow unit. So the pint of blood comes out of a person's body, it goes into a bag, then it gets tested, it gets stored, it gets transported. So there are lots of things that happen within the process. But this individual unit that you're looking at is 1 pint of blood. Yeah. So let's look at an example of a process at a Presbyterian hospital in Philadelphia. And we are specifically going to be looking at something called the angiography suite. Now here is a Gantt chart for the interventional radiology department where the angiography suite exists. So you have people coming in, so you have patients come in, they register, they go through an initial consultation to figure out where they are going to go. So they have two different rooms that they can go to. They can either go to the angiography suite, which is where they'll look, there's a big angiography equipment that you go through a process where they measure your health of the heart and whatnot. But there's also a secondary room. If the condition that you have is not a serious one, they send you to a secondary room where the tests are much simpler. So they have to decide which room to send you to. And as the consultation is happening, room can be prepared at the same time. And then the patient gets prepared, so your vitals are taken and so on, and maybe you get into the machine gets attached to you, and finally the procedure happens. then the machine gets removed from you, and then you go through recovery. Now, some of these processes you'll notice that happen simultaneously. That is why their starting point and ending points are similar, are as part of other processes also. Now, this is called a Gantt chart, where you have time on the x-axis and all the different steps of the process, and you draw bars to represent how long they take. And I'm absolutely sure all of you know what Gantt charts are. I mean, everybody is in project management, so you know what Gantt charts are. So I'm not gonna spend time explaining to you. So this is the general activity that takes place. So if you look at a particular patient who came in at 12:30, they did registration, they went through initial consultation, and then they waited. So this is the waiting time for the patient. Then they got prepared in a room. They went into the preparation room. The room was prepared for the patient. Then the patient themselves were prepared with the initial vitals and attaching the machine and whatnot. They went through the procedure. The equipment got removed. They were in recovery, and there was some consultation as they were recovering from their procedure also, right? So here all the things in gray are the ones that take place in the angiography suite. The ones in black happen in ancillary rooms outside, right? That's something to keep in mind. So this is a process. So patient coming in and patient leaving, that whole procedure, that's a process, and that's what we're trying to that's kind of thing that we're trying to analyze here. So here is a list of patients that came in. Of the first 11 patients that came in, only 6 of them needed to go to the main room, which is the angiography suite. The rest just went to the secondary room. And for those patients, you'll notice that this was how they went in. So you had patient 1, then you did patient 4, 6, 8, and 9. So these are the patients who went into the angiography suite itself. Okay. So this is an example of a process, and this is an example of how a process is mapped out. Now, when looking at process and trying to figure out, well, is this process efficient? Is this process running the way it should be running? Can we do better? So to answer all of these questions, we have to start at the basics. So look at some basic things that you need to know to analyze a process. The three main metrics that you need when analyzing a process are: what is the inventory, what is the flow unit that you're looking at, how many flow units are there in the process, then it's the flow rate, the rate at which flow units enter and leave the process, and flow time, how long is it between entering and leaving the process for a particular flow unit, right? So here's an example of a call center. So the flow rate is on average, let's say 11 callers call per minute. That is the flow rate. The time is, let's say on an average, a person spends 2.5 minutes at the call center. With the average time is 2.5 minutes. Some might take more, some might take less. But with that, you can calculate that the average inventory is, if you have 11 callers per minute and they spend about 2.5 minutes each, it's about 27.5 callers. That's the average amount of inventory that you hold at any point in time. Again, these are very simple concepts, but it is good to understand the structure of how you can analyze these processes, right? And anybody who's done any sort of management consultancy probably knows all of this already, right? So here are examples of 4 different processes. Let's look at the immigration one, where the flow unit is a particular application for an immigration benefit. The flow rate is how many of these get done in a year. So it's about approximately 6.3 million cases per year. But the flow time is 7.6 months. That's the average amount of time that it takes. And the amount of inventory that you have is 4 million cases. Now, how do I know it is 4 million cases? Well, that is based on something called a Little's Law, which we'll come to in a second. Now, how do you measure process performance? How do you look at process performance? And what are the 3 major metrics that we define? Inventory, flow rate, and flow time. What do they tell you about process performance? So always remember that maximizing flow rate, increasing flow rate, avoid situations where you have insufficient supply. And from a profit perspective, higher flow rate always translates to more revenues. That's the best way. So the more items that you can get through your process, the more revenues you are going to make. Now, the problem is a reduction in inventory yields to a reduction in flow time, but as we saw in the pandemic, always having low inventory can be problematic when there are shocks to the system. When everything is going according to plan, then there are no problems, but when there are shocks to the system, well, having low inventory is a problem. So this is what the three simple metrics tell you about process performance, and they are related to each other by something called the Little's Law. So Little's Law, basically named after John Little, says that the average amount of inventory that you have on hand is the average flow rate times the average flow time, and this does not depend upon any randomness either in flow time or flow rate, because nothing is exactly fixed. Even in, let's say that you're looking at a assembly line for a car, the amount of time it takes for one car to go through that should be fixed, right? Because everything is done by machines, but there are small variations. One might take a few minutes extra, one might take a few minutes less, because maybe something, when a particular machine put down a mold, it was not perfectly aligned and it took a couple of seconds for the aligning to happen. So it's never exactly the same, but you can look at it approximately being the same. But even with all of those randomness, this Little's Law is always satisfied, right? Because we are just looking at average values and we're not looking at the actual randomness itself. Now, Little's Law is also underlying the computation of two very important ideas known as inventory turns and cost of individual inventory. So what I will do is I'll talk about inventory turns and the cost of inventory, and then we'll end this video here, and then I'll move on to the next video where we'll talk about how you actually measure the performance of a particular process and how do you analyze that. So let's quickly talk about the idea of inventory costs and inventory turns. So let's take the examples of Kohl's and Walmart. So here we are looking at the flow unit that we are looking at here is a single dollar. So Kohl's gets money, either capital costs or whatever, so they have a single dollar that they invest into the business. How long does it take for it to come out as revenue? That's the whole process. That's what Kohl's did for the whole year, right? So here is some data from Kohl's. Kohl's revenue is 15.99955 trillion, because all of this is basically in millions of dollars, right? Their cost of goods sold is 10.36 trillion, and the inventory cost is 2.59 trillion. Right. So with that, using Little's Law, we can calculate something called the inventory turns. Let's first calculate inventory turns, and then we look at inventory costs. Let's begin at the basics. So we know the flow rate. Flow rate we know is 10.36 million, 10,360 million per year. And we know that the inventory is 2.59 million per year. So using the flow rate and inventory, we can calculate flow time. And flow time is 2.59 million divided by 2.59 trillion divided by 10.36 trillion. That gives us 0.25 years, because year is the measure that we have here. And it translates out to about 91.25 days. So this means that on average, every dollar that Kohl's invests comes back to it as a revenue. It takes 91.25 days for that to happen. So that's basically Kohl's inventory turns, right? So sorry, not inventory turns. That's how long it takes for the money to come back. So that's basically revenue turns, right? Now with that, we can now calculate the inventory turns. So we say that Kohl's turns over its inventory in 365 days a year. Of the within those 365, because it takes 91.25 days for $1 invested to come back, it does this approximately 4 times a year. So 365 divided by 91 is actually 3.2 or something like that, but you can round that up. So approximately 4 times a year. So this measure is called the inventory turns. And actually, this is very close to 4 times a year. So it's not 3.15, it's like 3.9 something. So it's 4 times a year approximately. So this measure is called inventory turns, and basically you can think of it as 1 divided by flow time, because if you look at flow time is 91.25 days, and if I divide it by 1 divided by 91.25 days will give me inventory terms as per day, but we don't want inventory terms per day. We want it for the whole year. We multiply that with 365, so that's why we get it as 4 times a year. We can do a similar calculation, and you'll notice that Walmart's inventory turns is 9.35 turns per year. So Kohl's inventory is very stable from year to year. For example, Kohl's inventory was 3.575 million in 2020, 3.475 million in 2019, and so on. So it's pretty stable year over year. So that's something to keep in mind. But either way, this is how you calculate inventory turns, right? You calculate the flow rate for a dollar to get converted from investment to revenue, and then you divide 365 by that number. It will give you the inventory turns per year, right? So the other important thing to calculate is the per unit inventory cost. Now, given the annual cost of inventory and the inventory turnover information, can we compute the cost of per unit inventory? Now, this is actually a very, very difficult cost to calculate. Now, one of the things we'll assume here is we'll assume that we know this, that it is 20, the holding cost, annual holding cost is 20% per year. But that itself is actually very, very difficult to calculate. So let's say that we, it's not 3.15, it's actually 4. Let's say that we calculated that Kohl's inventory turns is 3.15, and their holding cost, let's say holding cost is 20% per year, then the inventory cost per unit will be this 20% divided by their inventory turns. Now, the actual number that we calculated for inventory turns was 4. So it'll be 20 divided by 4, which is 5% is the cost of goods sold. So that's the cost per unit. So what is the cost per unit? It's about 5% of the cost of goods sold. And that's the idea. So these are some of the basic things that you need to know to understand what is process. So when doing process analysis, inventories play a very, very important role. So it is important to know what kind of inventory we have, what kind of costs are associated with it, and track it very, very carefully. Now, the textbook has some more information about the different kinds of inventories that you can hold. You have safety inventories, cycle inventories, you have work in process inventories, and so on. So it's important to know in which scenario you hold which inventory. Seasonal inventory is another one, so that's something, but you can read that in the textbook. And I'm going to end this video here, and in the next video we'll talk about how you analyze the performance of a process, right? See you in the next one. Take care.